So today we're going to talk about density, and the definition of density kind of gives light to its formula. The definition of density is the amount of stuff in a given area, and the amount of stuff is represented by the mass, and the given area is represented by the volume. So the definition, stuff in an area, or the amount of matter in a given amount of space, gives you the formula of density that you can see right here. The formula of density is D equals M over V. We're going to use our lightsaber pointer today. So density is equal to the mass divided by the volume. How much stuff, mass, is in a given area, volume. So again, D stands for density, M stands for mass, V stands for volume. And the units that we talk about, mass is usually measured in grams for density problems. Very occasionally you may see kilograms, and that's okay. Volume is usually measured in milliliters, and I'm going to put slash centimeters cubed because we are going to remember that these two are interchangeable. 1 milliliter is exactly equal to 1 centimeter cubed. So when you use one, you technically can use the other. And then again, very occasionally you'll get liters as a measurement there. Now the funny thing is the density unit kind of comes from the unit of mass and the unit of density, because you see in the formula density equals mass over volume. So the unit comes from that same thing. So if the unit for mass that you used is grams and your unit for volume that you use is milliliters, well then the unit of density is grams per milliliters. But that can kind of change whether you had grams per centimeter cubed, grams per liter. The only rule is they have to agree. So for example, if you're given a density measurement, you're given a density and it says it's 1 gram per milliliter, then the mass has to be in grams and the volume has to be in milliliter. So they technically can be any unit you want, they just have to agree with each other. Now you can just remember the formula D equals M over V, plug in mass, plug in volume every time. Or there's a little trick, this little triangle here. It's called the density triangle. If you fill in the letters, so you start with D, M at the top, and V. Think of like the place where you go to get your license. This actually gives us a little idea of how you can get the other formulas. So you have a choice. You can either just always plug everything into D equals M over V. Just remember one formula and then use your algebra skills to solve. Or the way this triangle works, you cover up the letter you're looking for, and then the formula is actually revealed. So if anything's over something, M over V. So for example, if you cover up density, you'll see that the formula for density is M over V, which is exactly what we have here. Density equals mass over volume. If you cover up the V, for example, V equals M over D, mass over density. Or if you cover up M, they're next to each other, so mass equals D times V. So it's really up to you which way you choose to remember the formulas. Just remembering D equals M over V is completely sufficient. So now we're going to do a couple practice problems here. Remember, when we do practice problems, you need to read the problem first. So you read the problem, you kind of highlight, underline, circle the important information. Then you figure out what knowns you're given and then what you're solving for. It's really important that you read the entire problem. So this says, a student determines that a piece of unknown material has a mass of 5.854 grams and a volume of 7.57 centimeters cubed. What is the density of this material? So you have a couple choices here. You can either write next to it, write the letters, so I see, okay, this is a mass for sure, because it says basically straight out, this is the mass. And again, this is the volume for sure, because it says this is the volume. And it asks you to solve here for the density D. So you see very quickly, you have an M and a V, and you're solving for the density D. Another option is to write the knowns on the side here. So you can write out from the problem, you're kind of just copying this down from the problem, your mass and your volume, and that way you can see it very quickly what math you need to do and what you're solving for, and also what your units are. So if I have a mass of 5.854 grams, a volume of 7.57 centimeters cubed, then very simply I see I'm solving for the density. You're going to remember the formula for density is m over v. And really this is just a matter of plugging in. So you're going to do m is 5.854 divided by the volume, 7.57. Always good to round to 2 decimal places when you're doing any kind of math like this. That's just a good, there is the sig figs, and actually you'll see the sig figs kind of agree, but what you're going to do is you should always really just round to 2 decimal places. That's generally going to give you the answer that you want. And here we have a density of 0.77. Now remember those units. The units have to agree. So see here I have a gram and I have a centimeter cubed. So your unit will be grams per centimeter cubed. And then box off your answer, always helpful. So you can see right away what your answer is. If you're still confused about where those units come from, if you look at the formula, the unit for your mass is a gram, the unit for your volume is a centimeter cubed. Remember, another way to write a fraction like this is to write it like this. It's just a different format, and that's where the unit comes from. So if we do the next problem, iron has a known density of 7.87 grams per centimeter cubed. What would be the mass of a 2.5 centimeter piece of iron? So here's where you really have to read. If you were just trying to pull out the numbers, you might get confused here. The question is, what would be the mass? So you're actually solving for the m, for the mass, because 2.5 centimeters cubed is a volume unit. And what could happen is you could think that this volume unit is actually your mass, and you're going to get the wrong answer. So we're solving for the mass. I have a V and I have a D. So right there I'm just kind of plugging in. I'm solving for mass. So you can either plug it right in to the D equals M over V equation, or you can remember our density triangle, and the formula for mass is D times V. So I'm just going to take 7.87 and multiply that by 2.5. Again, I'm going to round to 2 decimal places with my answer. Make sure that you multiply if you're going to use this equation. And I should get 19.68. Okay, so now I need a unit again. Right here I see that my density is in grams. So that would be my unit answer is grams. Now when I say they have to agree, what I mean here is see how in density this volume centimeter cubed, you have to make sure that the volume given is the same unit. If it wasn't, you would have to convert the volume into the correct unit. Let's go on to the next one. Mercury has a density of 13.5 grams per centimeter cubed. How much space, is the question, would 50 grams of mercury occupy? So again, if you didn't read this off the top, you might get confused. It gives you a density, and when it says how much space, that's a volume. It's asking you to solve for V, and then 50 grams is actually your mass. Remember, grams measure mass. Our units agree. I have a gram and a gram, so I can just go ahead, find the formula, and plug in. So this time I'm solving for volume, and if I use my triangle, I see volume equals mass over density. So then I simply plug in the mass from the problem, 50 grams, over 13.5, my density. I'm going to divide, round to 2 decimals, and I get 3.70. Now my unit, remember, comes from the density unit, centimeters cubed. Okay, last problem. It says calculate the density of a material that has a mass of 52.45 grams and a volume of 13.5 milliliters. So we're kind of ending with a straightforward. It's asking you to solve for the density. You have an mass M and a volume V. So our regular density formula, D equals M over V. Plug in here. So we do 52.45 0.45. Our units agree, remember, grams, grams, milliliters, milliliters. Then we're going to do 13.5. So we're going to do 15.45 divided by 13.5. Round to 2 decimals and you should get 3.89 grams per milliliter. So again, the units come from, for density, the unit of mass, the gram, and the unit of volume, the milliliter.